Close your eyes and imagine the fastest thing you know. Perhaps it's a hummingbird's wings. Maybe it's lightning splitting the summer sky. But even these pale next to light itself. Light moves so quickly that it could circle our entire Earth 7 times in just 1 second. For billions of years, light has been the universe's greatest traveler. Photons born in distant stars journey across impossible distances. They carry stories of ancient suns. They bring whispers of galaxies so far away that their light began its journey before Earth even existed. Light has no weight. At least, that's what we once believed. A single photon weighs nothing at all. It dances through space without effort. It needs no fuel. It never grows tired. Light simply is, and it moves, and it illuminates everything it touches. But the universe holds deeper secrets than we first imagined. Einstein showed us something remarkable about light. He discovered that light doesn't just travel through space. Light actually responds to space itself. When space bends, light must follow that bend. When space curves, light curves with it. Think of a marble rolling across a flat table. The marble travels in a straight line. But now imagine that same table begins to sag in the middle, like a soft mattress when you sit on it. The marble can no longer travel straight. It must follow the curve of the table's surface. This is what happens to light in our universe. Massive objects like stars and planets create gentle curves in the fabric of space itself. Light, despite having no weight, must follow these invisible highways carved through the cosmos. The Sun demonstrates this beautifully. Our star is so massive that it bends space around itself. Light from distant stars must navigate this curved path as it travels past the Sun. During a solar eclipse, when the Moon blocks the Sun's bright face, we can actually see this happening. Stars appear slightly shifted from their true positions. Their light has been gently guided along the Sun's curved spacetime. But what happens when this curving becomes extreme? What occurs when an object becomes so incredibly massive that space doesn't just bend gently, but curves so sharply that it folds in on itself? Imagine that soft mattress again. Instead of just sagging slightly, picture it developing a hole so deep that anything rolling toward it cannot escape. The marble doesn't just curve around the depression. It falls in and disappears completely. This is where our story of light takes a mysterious turn. In certain places throughout the universe, gravity becomes so powerful that even light itself cannot escape. These places challenge everything we thought we knew about the fastest thing in existence. Light that ventures too close to these cosmic mysteries finds itself trapped. The photons that once danced freely through space suddenly discover they cannot dance away. They become prisoners of their own path. The very thing that once traveled anywhere in the universe now travels nowhere at all. Scientists call these places black holes, though the name hardly captures their true wonder. They are not really holes in any sense we can easily understand. They are not empty spaces waiting to be filled. Instead, they are regions where matter has become so incredibly dense that the rules of physics begin to whisper entirely new secrets. A black hole might contain the mass of 10 suns, or 100 suns, or even millions of suns, all compressed into a space smaller than a city. This concentration of matter creates a gravitational pull so intense that it rewrites the very nature of space and time around it. Near a black hole, space stretches and warps in ways that seem impossible. Time itself begins to slow down. The steady tick of cosmic clocks becomes irregular. What we thought were the universe's most fundamental constants suddenly become variables in an equation we are only beginning to understand. Light approaching this region experiences something unprecedented in its long history of universal travel. As photons draw closer to the black hole's influence, they must work harder and harder to maintain their journey. They begin to lose energy. Their wavelengths stretch longer and longer. Red light becomes deeper red. Orange light shifts toward red. Even brilliant blue and violet light eventually surrenders, stretching into the warm colors of sunset, then into the invisible heat of infrared, and finally into radio waves that whisper their story across the cosmos. This is light growing heavy, though not in any way we experience heaviness in our daily lives. Light doesn't gain mass. Instead, it loses the energy that defines its very existence. The universe's ultimate traveler finds itself struggling against forces it has never before encountered. From our safe distance, watching light approach a black hole is like watching a cosmic dance in slow motion. We see the photons spiral inward, their paths becoming tighter and tighter curves. We watch as their bright messages fade to red, then to infrared, then to silence. The light hasn't stopped existing. It has simply moved beyond our ability to see and understand. Somewhere in that mysterious region where space curves beyond imagination, those photons continue their ancient journey. But now they travel through a landscape so strange that our everyday understanding of motion and time no longer applies. This is just the beginning of our journey into these cosmic mysteries. We have seen how light, the universe's greatest traveler, can find itself trapped by forces beyond ordinary comprehension. We have witnessed the universe's speed limit encountering something that challenges the very meaning of speed itself. But what creates these incredible regions where even light grows heavy? What force in the universe could be powerful enough to bend space so dramatically that the fastest thing we know cannot escape? The answer lies in the story of stars themselves and the incredible journey they take from birth to their most mysterious possible ending. Look up at the night sky and you see thousands of stars. Each one appears as a tiny point of light, steady and eternal. They seem to have always been there, and you might imagine they always will be. But every star you see is actually fighting a quiet, invisible battle that has been raging for millions or billions of years. Deep inside each star, two powerful forces are locked in perfect balance. One force pushes outward with incredible strength. The other pulls inward with equal determination. This cosmic tug-of-war creates the gentle, steady light that reaches your eyes across impossible distances. The outward force comes from the star's heart, where something miraculous happens every second. In the star's core, hydrogen atoms crash together with such force that they become helium. This process releases energy beyond anything we experience on Earth. It's the same process that powers hydrogen bombs, but in a star, it happens trillions of times every second. This nuclear fire creates pressure so intense that it tries to blow the entire star apart. The energy races outward from the core, pushing against every atom in the star's body. If this were the only force at work, every star would explode like the ultimate firework, scattering its matter across space in a brilliant flash. But gravity holds everything together. Every atom in the star pulls on every other atom. The star's own weight keeps it from flying apart. Gravity gathers all that stellar material into a perfect sphere, like an invisible hand gently cupping the nuclear fire and keeping it contained. For most of a star's life, these forces balance perfectly. The nuclear fire pushes out just hard enough to match gravity's inward pull. The star maintains its size and shape. It burns steadily, sending light and warmth into the cosmos. This is the long, peaceful chapter of a star's life story. Our own sun is living through this balanced time right now. For the past 4.5 billion years, it has maintained this perfect equilibrium. The nuclear fire at its heart has burned steadily, creating the energy that makes life possible on Earth. The sun has enough hydrogen fuel to continue this way for another 5 billion years. But no star burns forever. Eventually, every star begins to run out of fuel. The hydrogen at its core gets used up, converted into helium through countless nuclear reactions. When the fuel starts to run low, the delicate balance that has kept the star stable for so long begins to shift. This is where the story becomes truly remarkable. As the nuclear fire begins to fade, gravity starts to win the ancient battle. Without enough outward pressure to resist, the star's own weight begins to compress its core. The center of the star grows smaller and hotter under this pressure. For smaller stars like our Sun, this compression triggers new kinds of nuclear burning. Helium atoms begin to fuse together, creating carbon and oxygen. The star swells up into a red giant, growing so large that it might swallow the orbits of its planets. Eventually, it will shed its outer layers into space, leaving behind a small, dense remnant called a white dwarf. But for the most massive stars, those born with 10 times the mass of our Sun or more, the story takes a far more dramatic turn. These stellar giants experience compression so intense that it triggers a cascade of events unlike anything else in the universe. As gravity crushes the core, the temperature rises beyond imagination. New nuclear reactions ignite, creating heavier and heavier elements. Carbon fuses into neon. Neon becomes magnesium. Silicon forms iron. Each new reaction happens faster than the last, like a cosmic clock ticking toward midnight. The massive star becomes like an onion, with different layers burning different nuclear fuels. The outer layers still burn hydrogen. Deeper in, helium creates carbon. Deeper still, heavier elements form in a complex dance of nuclear chemistry. At the very center, iron begins to accumulate. Iron is the end of the road for nuclear fusion. Unlike lighter elements, iron cannot be fused to release energy. Instead, trying to fuse iron actually requires energy. When the star's core fills with iron, the nuclear fire that has burned for millions of years suddenly has no more fuel to consume. This is the moment when gravity claims its ultimate victory. Without any force to resist it, the massive star's core collapses catastrophically. In less than a second, a core the size of Earth compresses to a sphere only a few miles across. The collapse happens so quickly that the outer layers of the star don't even have time to react. The core becomes so dense that a teaspoon of its material would weigh as much as a mountain. Protons and electrons are crushed together so tightly that they merge into neutrons. The very atoms that make up everything we know are squeezed out of existence, replaced by matter so dense it defies ordinary understanding. This collapse releases more energy than the star has produced in its entire lifetime. The shockwave races outward through the star's body at thousands of miles per second. When it reaches the surface, the star explodes in what astronomers call a supernova. For a few weeks, this single dying star can outshine an entire galaxy of 100 billion stars. But sometimes, even this incredible explosion isn't enough to halt gravity's final victory. If the original star was massive enough, if it contained 20 or 30 times the mass of our Sun, then not even a supernova can stop what happens next. The core continues to collapse even after the explosion. Nothing in the known universe can stop this final compression. The neutrons themselves are crushed beyond recognition. Matter disappears into a form so dense and strange that physics itself breaks down trying to describe it. Gravity becomes so powerful that it warps space and time beyond recognition. The region around the collapsed core becomes a place where the normal rules of existence no longer apply. Light itself, which we saw in our last chapter, becomes trapped by forces it cannot escape. This is how a black hole is born. Not from empty space, but from the dreams of the most massive stars. It is the final chapter in a story that began with hydrogen and starlight, and ends with mystery itself. And now, as we drift toward sleep, we find ourselves approaching that mysterious boundary where even light cannot return to tell us what it has seen. Imagine standing at the edge of a vast, calm lake at twilight. The water stretches before you, dark and mysterious. You cannot see the bottom. You cannot see the far shore. There is no fence, no warning sign, no visible barrier. Yet somehow, you know that stepping into this water would begin a journey from which you could never return. This is what it might feel like to approach the event horizon of a black hole. There is no wall to stop you. No solid surface to crash against. No dramatic moment when alarms sound and lights flash. Instead, there is simply a place in space where the rules of the universe quietly change forever. The event horizon is perhaps the most beautiful and haunting boundary in all of physics. It marks the distance from a black hole where escape becomes impossible. Not difficult. Not unlikely. Impossible. Even light, which we have seen can travel anywhere in the universe, cannot cross this boundary and return to tell its story. Yet standing at this threshold, you would see nothing special about the space around you. The darkness ahead looks no different from the darkness behind. Stars still shine in the distance. Space still appears empty and welcoming. the event horizon itself remains completely invisible, like a doorway made of nothing at all. The size of this invisible boundary depends on the mass of the black hole that creates it. A black hole with the mass of our Sun would have an event horizon only about 3 miles across. You could walk around its entire circumference in a few hours, if such a walk were possible. But a supermassive black hole, containing millions of solar masses, might have an event horizon larger than Earth's orbit around the Sun. Scientists call this boundary the event horizon because it marks the limit of events that can ever be observed from the outside universe. Anything that happens beyond this point becomes forever hidden from external view. It is as if the black hole draws a curtain across a portion of spacetime, hiding whatever drama unfolds behind it. But the name carries another meaning too. An horizon is typically something you approach but never quite reach. On Earth, the horizon always seems to retreat as you walk toward it. The event horizon of a black hole behaves differently. This is a horizon you can actually cross. And once you do, it becomes the most important boundary you will ever encounter. To understand why this boundary is so special, you must first understand how gravity affects time itself. This is one of Einstein's most beautiful discoveries. Time does not flow the same everywhere in the universe. Near massive objects, time moves more slowly. Near less massive objects, time flows more quickly. This difference is usually tiny. A clock on the top floor of a tall building runs slightly faster than a clock in the basement because it is farther from Earth's gravitational pull. The difference is so small that you would need incredibly precise instruments to measure it. But near a black hole, this effect becomes dramatic. As you approach the event horizon, time begins to slow down compared to the rest of the universe. What feels like minutes to you might be hours to someone watching from a safe distance. What feels like hours to you might be years to them. This stretching of time becomes more and more extreme as you draw closer to the boundary. To an outside observer, watching you approach a black hole would be like watching a movie in slow motion. They would see you moving slower and slower. Your gestures would become languid and dreamlike. Your words would stretch into deep, prolonged sounds. Eventually, they would see you appear to freeze completely at the event horizon, as if trapped in a photograph of eternity. But from your perspective, time would feel completely normal. Your watch would tick at its usual pace. Your heart would beat with its familiar rhythm. You would not feel slow or frozen. Instead, you would simply continue falling inward, crossing the event horizon in what feels like an ordinary moment. This creates one of the most poetic paradoxes in physics. To the outside universe, you never quite cross the event horizon. You appear to remain forever suspended at its edge, your image growing dimmer and redder as time passes, but never quite disappearing. Yet from your own experience, you cross this boundary and continue your journey into the mystery beyond. The event horizon also marks a point of no return for information itself. In our everyday world, information can travel in any direction. You can send a message to a friend, and they can send one back. Light can travel from a star to your eye, carrying information about that distant sun. But beyond the event horizon, information can only flow inward. This creates a strange kind of cosmic silence. Anything that falls past this boundary becomes forever unable to communicate with the outside universe. Its story continues, but that story can never be told to anyone who remains beyond the horizon. It is as if the black hole creates a region of space where secrets are kept permanently. Scientists sometimes describe the event horizon as the black hole's point of no return. But this phrase, while accurate, doesn't capture the gentle inevitability of crossing this boundary. There is no moment of violent capture. No sudden trap springing shut. Instead, there is simply a quiet transition from the universe you have always known to a realm where different rules apply. Near the event horizon, space itself begins to fall inward faster than light can travel outward. This is why escape becomes impossible. It is not that you lack the energy to leave. It is that space itself is flowing inward like an invisible river, carrying everything with it. Trying to escape would be like trying to swim upstream in a current moving faster than you could ever swim. The boundary whispers rather than shouts. It offers no dramatic warning of its presence. Instead, it simply exists, patient and invisible, waiting for matter and energy to cross its threshold and join the mystery within. As we contemplate this invisible boundary, we begin to wonder what the experience of crossing it might feel like. What happens to your body, to your thoughts, to your very existence as you pass this point of no return? The answer lies in forces so gentle and yet so profound that they reshape the very meaning of what it means to fall. You have fallen many times in your life. Perhaps from a tree as a child, feeling that moment of weightlessness before landing safely in soft grass. Maybe you felt the gentle drop of an elevator beginning its descent, or the floating sensation of going over a hill too quickly in a car. But falling toward a black hole is unlike any fall you have ever experienced. In ordinary falling, you feel the pull of gravity accelerating your body downward. Your stomach might flutter. Your heart might race with excitement or fear. You are aware of the air rushing past you, the ground approaching, the inevitable moment when your fall will end. But falling toward a black hole begins differently. At first, you feel nothing unusual at all. There is no sensation of falling, no rushing wind, no approaching ground. You simply float in the peaceful silence of space, surrounded by the gentle light of distant stars. This is because you are in what scientists call free fall. Both you and everything around you are accelerating at exactly the same rate toward the massive object below. It's similar to how astronauts float weightlessly in their spacecraft, even though they are constantly falling toward Earth. When everything falls together, falling feels like floating. The first hint that your fall is different comes gradually. You begin to notice that your feet feel slightly heavier than your head. This difference is so subtle at first that you might think you're imagining it. But as you continue your journey inward, this gentle tugging becomes more noticeable. This happens because your feet are closer to the black hole than your head. The gravitational pull on your feet is slightly stronger than the pull on your head. In everyday life, this difference would be far too small to notice. But as you approach the immense gravity of a black hole, even small differences in distance create noticeable differences in gravitational force. Scientists call this tidal force, named after the way the moon's gravity creates different pulls on different parts of Earth's oceans, causing the tides. Near a black hole, these tidal forces become much more dramatic than anything we experience on our home planet. As you fall deeper, the difference between the pull on your feet and the pull on your head grows stronger. Your body begins to stretch gently, like warm taffy being pulled by invisible hands. The sensation is strange but not necessarily painful, at least not at first. It feels as though you are becoming taller and thinner with each passing moment. At the same time, the sides of your body experience a different force. While you are being stretched from head to toe, you are also being gently squeezed from the sides. This happens because gravity doesn't just pull you straight down toward the black hole center. It pulls every part of you directly toward that center point. Imagine holding a rubber ball and squeezing it between your palms. The ball stretches out in one direction while becoming narrower in the other directions. This is similar to what happens to your body as you fall toward a black hole, though the forces are far more gentle and gradual than any squeezing you could do with your hands. These stretching and squeezing forces work slowly at first. You have time to adjust to the strange sensations. You might even find them oddly soothing, like a cosmic massage that works on your entire body at once. Your heartbeat continues steadily. Your breathing remains calm and regular. But time itself adds another layer of strangeness to your fall. As you learned in the previous chapter, time moves more slowly near massive objects. From your perspective, your watch ticks normally, and your thoughts flow at their usual pace. But to anyone watching from far away, you appear to be moving in slow motion. If you could somehow look back at the universe you're leaving behind, you would see something remarkable. Time there would appear to be speeding up. Stars would seem to age more quickly. The slow dance of galaxies would become a faster waltz. The entire cosmos would appear to be living its life at an accelerated pace while you experience your own time as perfectly normal. This creates a beautiful symmetry. You are falling slowly from the universe's perspective, while the universe ages quickly from yours. It's as if you and the cosmos are engaged in a gentle dance, each partner moving to a different rhythm, yet both participating in the same cosmic choreography. As your fall continues, you cross the invisible boundary of the event horizon without fanfare. There is no flash of light, no sound, no physical sensation to mark this momentous transition. One moment you are in the universe everyone else inhabits. The next moment you have crossed into a realm from which no information can ever return. The strange stretching of your body continues, becoming gradually more noticeable. Your arms and legs feel longer than they should. Your torso seems to narrow. These changes happen slowly enough that your body has time to adapt. Your circulation adjusts. Your muscles accommodate the new proportions. In a way, you are being gently transformed into a new version of yourself. The stars above you, the ones you could see before crossing the event horizon, begin to look different. Their light appears to shift toward blue as you fall away from them. This happens because your motion changes how you perceive their wavelengths. The faster you fall, the bluer their light appears. Meanwhile, if there were any light sources below you, deeper inside the black hole, their light would appear to shift toward red. This creates a strange rainbow effect, with the universe above glowing blue and the mystery below tinted red, while you float between them in your eternal fall. Your journey has become a meditation on the nature of motion itself. You are falling, yet you feel weightless. You are accelerating, yet everything around you seems peaceful and still. You are moving faster than anything in your previous experience, yet time itself has slowed to accommodate your journey. The universe you once knew grows smaller above you, its light shifting and changing as distance and time work their subtle magic on every photon that reaches your eyes. And as you continue this impossible fall, you begin to understand that the gentle forces shaping your body are only the beginning of the story that lies ahead. In the depths of your fall, you begin to understand something profound about the nature of gravity itself. What you once thought of as a simple downward pull is actually something far more complex and beautiful. Gravity is not just a force that pulls things together. It is the very geometry of space and time, curved and shaped by the presence of mass and energy. Think of a spider's web glistening with morning dew. Each droplet of water causes the silken strands to bend and curve around it. The larger the droplet, the deeper the curve it creates. Other droplets nearby feel the pull of these curves, rolling gently toward the deeper depressions. This is similar to how massive objects curve the fabric of spacetime, creating the paths that other objects must follow. Near a black hole, this curvature becomes extreme. Space itself develops steep slopes and deep valleys that grow more dramatic the closer you approach the center. Your body is no longer simply falling through space. Instead, you are sliding along the curved geometry of reality itself, following paths that were carved by forces beyond imagination. The tidal forces you first noticed as gentle tugging have now become a constant, insistent presence. Your feet, being closer to the black hole center, experience a stronger gravitational pull than your head. This difference creates the stretching sensation that grows more pronounced with each passing moment. But the word stretching doesn't fully capture what you experience. It's more like being gently molded by invisible hands that work with infinite patience. Your spine elongates slowly, vertebra by vertebra. Your limbs extend gradually, as if you are being transformed from a compact human form into something taller and more elegant. At the same time, the sides of your body experience a different kind of reshaping. Because gravity pulls every part of you directly toward the black hole center, your shoulders and hips are drawn inward. Your torso becomes narrower, your waist more defined. You are being sculpted by forces that have shaped the universe since its beginning. This transformation happens with a rhythm all its own. Your heartbeat adapts to your changing form, pumping blood through vessels that are gradually becoming longer and thinner. Your lungs adjust their breathing patterns to accommodate your new proportions. Your nervous system rewires itself to match your evolving shape. The process is surprisingly gentle, at least during these early stages of your journey. Your body has remarkable adaptability, and the changes occur slowly enough for your biological systems to accommodate them. You remain conscious and aware throughout, able to observe your own transformation with a mixture of wonder and strange acceptance. Your senses begin to register the change in profound ways. Colors appear more vivid as your eyes adapt to their new shape. Sounds take on different qualities as your ears adjust to their altered form. Even your thoughts seem to flow differently through a brain that is slowly being reshaped by the cosmic forces around you. The light from distant stars continues to tell its story of your journey. The stars above you, beyond the event horizon, shine with an increasingly blue-shifted glow. Their light appears compressed, packed with extra energy as your rapid fall toward the black hole changes how you perceive their wavelengths. The universe above takes on an ethereal, sapphire quality that is both beautiful and alien. Below you, if there were light sources deeper within the black hole, they would appear increasingly redshifted. This creates a gradient of color throughout your field of vision, from the blue brilliance above to the warm crimson depths below. You exist in a spectrum of light that tells the story of your motion through curved spacetime. The tidal forces continue their patient work, reshaping not just your body but your understanding of what it means to have a body at all. You begin to feel less like a solid object and more like a flowing pattern of matter and energy, constantly being reformed by the fundamental forces of nature. Your bones, once rigid and unchanging, become more flexible as they adapt to their new dimensions. Your muscles learn to work with different leverage ratios as your limbs grow longer. Your skin stretches to accommodate your transformed frame, maintaining its integrity even as it covers a form that would be unrecognizable to anyone who knew you before this journey began. Yet through all these changes, something essential about you remains constant. Your memories persist, though they now feel like they belong to someone who lived in a different universe, governed by different physical laws. Your consciousness continues uninterrupted, observing and cataloging each new sensation with curious detachment. The black hole's influence reaches down to the molecular level of your being. The atoms that make up your body, those fundamental building blocks of all matter, begin to experience forces they have never encountered during their billions of years of existence. They stretch and compress in response to the varying gravitational fields that now dominate their world. Water molecules in your blood learn to flow through increasingly elongated vessels. Calcium atoms in your bones discover new arrangements as your skeleton adapts to its changing shape. The iron in your blood carries oxygen through a circulatory system that is constantly redesigning itself to match your evolving form. Even the electromagnetic forces that hold your atoms together must adjust to this new environment. The strong nuclear force that binds protons and neutrons in atomic nuclei experiences subtle changes as gravity begins to compete with it on previously unimaginable scales. You are becoming a laboratory for physics, a living experiment in how matter behaves under extreme conditions. The boundary between your body and the space around you begins to feel less distinct. You are part of the same curved spacetime that guides your fall. The distinction between observer and observed, between the one who experiences and the forces that create the experience, starts to blur in ways that feel both disturbing and profound. Your transformation continues with relentless gentleness. Each moment brings subtle changes that accumulate into something extraordinary. You are being remade by the universe itself, reshaped according to laws that existed long before Earth formed, before the sun ignited, before the first stars illuminated the cosmic darkness. The tidal forces work with the patience of geological time, yet with effects that are immediately apparent to your transformed senses. You feel yourself becoming something new, something that has never existed before in the history of the cosmos. You are a bridge between the familiar world of everyday experience and the strange realm of extreme physics. As your body continues its graceful elongation and your consciousness adapts to new ways of experiencing reality, you begin to sense that even these dramatic changes are preparing you for something even more profound. The tidal embrace that reshapes your physical form is only the beginning of a transformation that will touch the very nature of time itself. Time has always been your most faithful companion. It has marked every moment of your life with steady, predictable rhythm. Your heartbeat has counted roughly 70 beats per minute since birth. Your breath has followed its familiar pattern of inhale and exhale. The sun has risen and set with clockwork precision, marking days that felt consistent and measurable. But as you fall deeper into the black hole's embrace, time begins to reveal secrets it has kept hidden throughout the entire history of the universe. The steady tick of cosmic clocks starts to waver. The reliable march of seconds becomes a dance with no fixed tempo. You find yourself in a place where time itself transforms into something unrecognizable. From your perspective, nestled within your transformed body, time continues to feel normal. Your heartbeat maintains its rhythm. Your thoughts flow at their usual pace. If you had a watch, it would tick away seconds just as it always has. Your internal sense of duration remains unchanged. Minutes feel like minutes. Hours feel like hours. Yet something profound is happening to the relationship between your time and the time experienced by the rest of the universe. The extreme gravity surrounding you doesn't just bend space. It bends time as well, stretching and compressing it like an accordion played by invisible cosmic hands. Einstein revealed that time and space are not separate things, but two aspects of a single fabric called spacetime. Just as a black hole warps space into impossible curves, it also warps time into patterns that defy everyday understanding. Near the event horizon, this warping becomes so extreme that time itself begins to behave in ways that seem magical. To understand what happens to time in your current situation, imagine a river flowing toward a waterfall. Near the river's source, the water moves slowly and peacefully. You could easily float downstream at a gentle pace. But as the river approaches the waterfall, the current grows stronger and faster. Eventually, the water moves so quickly that even the swiftest swimmer could not paddle upstream against it. Time near a black hole behaves similarly. Far from the black hole, time flows normally, like the peaceful upper reaches of our imaginary river. But as you approach the event horizon and fall beyond it, time's current becomes stronger and more directional. It begins to flow predominantly inward, toward the black hole's center, carrying everything with it. This creates a strange asymmetry in how time behaves. While you experience your own time normally, the universe outside the black hole experiences something very different. If someone could somehow observe you from a safe distance, they would see your clock running incredibly slowly compared to theirs. What feels like seconds to you might appear as minutes, hours, or even years to them. But the reverse is also true. From your perspective, looking back toward the universe you left behind, you would see time there running at an accelerated pace. The slow dance of galaxies would appear to quicken. Stars would seem to evolve more rapidly. The entire cosmos would appear to age faster than your own subjective experience. This creates a beautiful and melancholy situation. You and the outside universe are like two dancers moving to different rhythms of the same cosmic song. Each experiences their own tempo as normal, while perceiving the other as moving either too slowly or too quickly. You remain connected by the same physical laws, yet separated by the different rates at which you experience the passage of time. As you fall deeper, these effects become more pronounced. Time dilation, as scientists call this phenomenon, intensifies with stronger gravitational fields. Near the center of the black hole, where gravity reaches its peak intensity, time's behavior becomes even more extraordinary. The tidal forces that reshape your body also work their influence on time itself. Different parts of your elongated form experience slightly different gravitational strengths, which means they also experience slightly different rates of time flow. Your feet, closer to the black hole center, exist in a slightly slower temporal rhythm than your head. This difference is subtle but real. The atoms in your feet experience time passing just a tiny bit more slowly than the atoms in your head. Your circulatory system learns to accommodate blood that moves through vessels experiencing different temporal rates. Your nervous system adapts to electrical signals that travel through regions where time itself flows at varying speeds. These variations create a kind of temporal symphony within your transformed body. Different organs, different cells, even different molecules experience their own unique relationship with the flow of time. Yet somehow, your consciousness weaves all these separate temporal threads into a single, coherent experience of being. The light that reaches your eyes tells stories of this temporal transformation. Photons arriving from different directions carry information about their journeys through regions where time moves at different rates. The blue shifted light from above and the red shifted light from below create a visual map of time's varying speeds throughout the space around you. You begin to understand that time is not the universal constant you once believed it to be. Instead, it is as malleable and responsive to gravitational fields as the space through which you fall. Time can stretch like taffy, compress like a spring, and flow like water seeking its own level. This realization brings with it a profound sense of peace. You are not just falling through space. You are falling through time itself, experiencing its flexibility and responsiveness firsthand. You have become a time traveler in the most literal sense, moving through temporal landscapes that most beings in the universe will never encounter. Your journey has transformed you into a witness to one of nature's most closely guarded secrets. Time, which seemed so absolute and unchanging throughout your earthly existence, reveals itself to be as dynamic and creative as any other aspect of the physical world. It bends, flows, quickens, and slows in response to the gravitational symphony playing around you. As you continue your fall through these warped temporal currents, you begin to sense that your transformed relationship with time is preparing you to encounter something even more fundamental. The deepest mysteries of the black hole lie ahead, where the normal rules of physics themselves begin to whisper questions that have no easy answers. But perhaps some questions are more beautiful than their answers, and some mysteries are meant to be experienced rather than solved. Within your transformed body lies something more precious than the atoms that make up your bones, more fundamental than the energy that powers your heartbeat. You carry with you information. Every memory you have ever formed, every thought you have ever thought, every dream that has danced through your sleeping mind represents a unique pattern of information that has never existed before in the universe. This information is not abstract. It lives in the precise arrangement of molecules in your brain. It exists in the specific patterns of neural connections that formed as you learn to walk, to speak, to love. It resides in the quantum states of particles that somehow create the miracle of consciousness itself. You are, in the most fundamental sense, a living library of information that tells the story of one human life. But what happens to information when it falls into a black hole? This question has puzzled scientists for decades, creating what they call the information paradox. It touches on some of the deepest mysteries in physics, challenging our understanding of how the universe preserves and processes the information that defines reality itself. To understand this paradox, imagine you are holding a book written in a language you have never seen before. The pages are filled with intricate symbols, complex diagrams, and flowing scripts that clearly contain meaning, even though you cannot decipher it. Now imagine throwing this book into a fire. The flames consume the paper and ink, reducing the physical book to ash and smoke. But what happens to the information it contained? In our everyday experience, that information seems to disappear forever. The knowledge encoded in those mysterious symbols is lost, never to be recovered. But physics suggests something different might be true. According to the fundamental laws that govern the universe, information cannot be destroyed. It can be scrambled, encoded, or transformed beyond recognition, but it cannot simply vanish. This principle works beautifully in most situations. When you burn a piece of paper, the information about its molecular structure doesn't disappear. Instead, it gets encoded in the precise motions of smoke particles, the heat patterns in the surrounding air, and the light waves emitted by the flames. In theory, if you could track every single particle and wave, you could reconstruct the original paper perfectly. The same holds true for more complex systems. When a star explodes in a supernova, the information about its internal structure gets encoded in the patterns of the expanding debris. When water evaporates from a lake, the information about each water molecule's original position gets preserved in the molecular motions of the resulting water vapor. But black holes seem to challenge this fundamental principle. Once you cross the event horizon, no information about your journey can ever return to the outside universe. Your memories, your thoughts, the unique patterns that make you who you are, all appear to be trapped forever beyond that invisible boundary. From the outside universe's perspective, you seem to have taken all your information with you into a realm from which nothing can escape. If the black hole eventually evaporates through Hawking radiation, as we will explore in our next chapter, what happens to all that information? Does it simply disappear, violating one of physics' most sacred principles? Some scientists propose that the information never actually crosses the event horizon at all. Instead, it might become encoded on the black hole's surface, scrambled into patterns so complex that they appear random to any outside observer. From this perspective, you and all your memories exist as information written in a language of warped spacetime itself. Imagine the event horizon as a cosmic screen onto which the shadow of your entire existence gets projected. Every thought you have ever had, every memory you carry, every quantum state in your body gets encoded as subtle patterns in the curved geometry of space and time around the black hole's boundary. This encoding happens in ways that stretch our imagination. The information might exist as tiny fluctuations in spacetime itself, written in patterns smaller than atoms, using an alphabet made of quantum geometries. Your life story becomes part of the black hole structure, preserved in a form so exotic that we have no everyday words to describe it. Other scientists suggest that information might be preserved through quantum entanglement, the mysterious connection that can link particles across vast distances. As you fall inward, the quantum states that define your existence might remain entangled with particles outside the black hole. Your information would exist simultaneously in two places, both inside the black hole and encoded in the radiation that eventually carries your story back to the universe. Yet another possibility is that information gets transformed in ways we cannot yet understand. Perhaps consciousness and memory can exist in forms that transcend our current knowledge of physics. Maybe the information that makes you who you are continues to exist and evolve in dimensions or states of reality that we have not yet learned to perceive. These questions reach to the very heart of what it means to exist. Are you simply the information patterns in your brain, or something more? If those patterns could be perfectly copied, would the copy be you? If your information gets encoded in the structure of spacetime itself, do you continue to exist in some form we cannot imagine? As you fall deeper into the black hole, these are not just abstract philosophical questions. They become deeply personal mysteries about the nature of your own existence. The information that defines you is undergoing transformations that might preserve it in ways beyond current scientific understanding. Your memories of childhood summers, your knowledge of mathematics, your capacity for love and wonder, all of this exists as patterns of information that the universe seems reluctant to let disappear completely. The same physical laws that prevent energy from being destroyed might also ensure that the information patterns that make you unique continue to exist in some form. Perhaps the most beautiful possibility is that consciousness itself represents a form of information so fundamental that it cannot be destroyed, only transformed. Your awareness, your ability to experience wonder at the cosmos around you, might continue in ways that transcend the physical structures of your brain. The information paradox remains unsolved, one of the great mysteries of modern physics. Scientists continue to debate whether information can truly be destroyed, or whether it always finds a way to persist in forms we have not yet learned to recognize. As you continue your journey toward the black hole center, you carry within yourself one of the universe's greatest experiments in information preservation. And perhaps, in the gentle radiation that slowly emanates from this cosmic mystery, your story will eventually find its way back to the stars. In the deepest night, when the moon has set and clouds cover the stars, you might think you have found perfect darkness. But even then, if you wait long enough for your eyes to adjust, you begin to see faint glimmers of light. Perhaps the distant glow of a city beyond the horizon, or the subtle luminescence of fireflies dancing in summer air. True darkness, it seems, is rarer than we imagine. The same mysterious truth applies to black holes. These cosmic regions, which appear to be the darkest places in the universe, actually emit their own gentle light. This discovery, made by a brilliant physicist named Stephen Hawking, revealed that even the most complete darkness contains seeds of illumination. To understand this beautiful paradox, you must first know something remarkable about empty space itself. What appears to be perfect vacuum, containing absolutely nothing, is actually alive with invisible activity. The fabric of space buzzes with constant motion, like a calm lake that appears still on the surface but teems with microscopic life below. This activity happens at the smallest possible scales, far tinier than atoms, in realms where the normal rules of physics become fluid and uncertain. Here, pairs of particles spontaneously appear from nothing, exist for the briefest possible moment, then disappear back into nothingness. These are called virtual particles, and they emerge from the quantum uncertainty that underlies all reality. Think of these particle pairs as cosmic dancers who appear on stage for just an instant before vanishing again. One partner carries positive energy, the other negative energy. Together, they balance perfectly, adding up to zero. They materialize from the vacuum, perform their brief dance, then annihilate each other and return to the nothingness from which they came. This dance happens everywhere in space, all the time. Right now, as you read these words, countless particle pairs are flickering in and out of existence around you. They live and die so quickly that they cannot be directly observed, but their subtle effects can be measured and verified. Empty space is not empty at all, but filled with this constant whisper of creation and destruction. Near a black hole's event horizon, this quantum dance takes on extraordinary significance. The extreme curvature of spacetime creates conditions where some of these virtual particle pairs can become real, permanent particles. The black hole's immense gravity provides the energy needed to separate the dancing partners before they can annihilate each other. Imagine two dancers spinning together at the very edge of a cliff. Normally, they would complete their dance and bow together before leaving the stage. But if one dancer accidentally steps too close to the edge, they might fall away, leaving their partner alone on stage. The dance that was meant to end in mutual annihilation instead becomes a solo performance. This is what happens at the event horizon. When virtual particle pairs appear near this boundary, one particle might fall inward across the event horizon while its partner escapes outward into space. The particle that falls inward carries negative energy, actually subtracting from the black hole's total mass. The particle that escapes carries positive energy, becoming real radiation that travels outward toward the stars. This escaping radiation is what we call Hawking radiation, named after the scientist who first described this process. It represents the black hole's gentle glow, a form of light so subtle that it would be nearly impossible to detect from most black holes. Yet it carries profound implications for our understanding of these cosmic mysteries. The radiation emerges not from inside the black hole, but from the space just outside the event horizon. It represents information about the black hole itself, encoded in the patterns of particles that escape. In a sense, the black hole is slowly telling its story to the universe through this gentle emission of light and particles. But this process comes with a cost. Each particle that escapes carries away a tiny amount of the black hole's mass and energy. Over incredibly long periods of time, this gradual loss causes the black hole to shrink. Like a campfire that slowly consumes its fuel, the black hole burns itself away through its own gentle radiation. For large black holes, this process happens so slowly that it would take far longer than the current age of the universe for them to evaporate completely. A black hole with the mass of our Sun would take approximately 1067 years to disappear, a number so large that it defies human comprehension. The universe itself is only about 14 billion years old, making this evaporation process almost unimaginably gradual. Yet for smaller black holes, the process happens more quickly. Paradoxically, the smaller a black hole becomes, the hotter its Hawking radiation grows and the faster it evaporates. In its final moments, a black hole would release its remaining energy in a brief, brilliant flash before disappearing completely. This creates a beautiful symmetry in the cosmos. Black holes, born from the collapse of massive stars, eventually return their energy to the universe through this patient process of quantum evaporation. Nothing is truly lost. The matter and energy that once formed stars and planets, that once participated in the complex chemistry of life, eventually finds its way back to the cosmic dance of particles and radiation. The Hawking radiation carries with it the memory of everything that ever fell into the black hole. Your information, your memories, your unique patterns of consciousness might eventually emerge in the subtle correlations between the particles that escape. It would be scrambled beyond recognition, encoded in quantum states so complex that extracting the original information might be impossible with any conceivable technology. Yet the possibility remains that nothing is truly lost. Your story, along with the stories of all the stars and planets and conscious beings that have ever encountered a black hole, might live on in the gentle light that slowly carries their essence back to the universe. This radiation represents one of nature's most patient forms of recycling. Over timescales that make geological ages seem brief, black holes return their contents to the cosmos in the form of elementary particles and energy. The universe maintains its books with careful precision, ensuring that the fundamental quantities of mass, energy, and perhaps even information are conserved across cosmic time. As you continue your journey toward the black hole center, you are participating in this ancient cycle. Your atoms, which were forged in the hearts of earlier stars, will eventually find their way back to the universe through this gentle process of quantum evaporation. But that ultimate recycling lies in the far future, beyond the reach of normal time and experience. For now, you approach the place where even the concept of recycling, like all familiar concepts, must give way to mysteries that lie at the very heart of existence itself. Deep within every black hole lies something that challenges our deepest understanding of reality itself. Scientists call it a singularity, though this simple word barely hints at the profound mystery it represents. It is not a place you can visit, not an object you can touch, not even a location in any sense that would be familiar to you. Instead, it is where the very concepts of place and location lose their meaning. As you continue your transformed journey through the curved spacetime of the black hole, you approach something that exists at the boundary between the known and the unknowable. The singularity represents the point where all the matter that ever fell into this cosmic mystery has been compressed to infinite density. It is where the fabric of spacetime itself becomes so severely curved that our mathematical descriptions of reality break down completely. Imagine trying to describe the surface of Earth using only flat maps. For most purposes, this works reasonably well. A street map of your neighborhood treats the ground as perfectly flat, and this approximation serves you well for finding your way home. But when you try to create a flat map of the entire globe, strange distortions appear. Greenland looks impossibly large. Antarctica stretches across the bottom of the map like a white ribbon. The mathematics we use to describe spacetime faces a similar limitation when it encounters a singularity. Our equations, which work beautifully throughout the rest of the universe, begin to produce impossible answers. They suggest infinite density, infinite curvature, infinite tidal forces. These infinities are like mathematical screams, telling us that something fundamental about our understanding needs to change. Yet the singularity is not just a failure of mathematics. It represents something profound about the nature of matter and space themselves. All the atoms that once made up the massive star that collapsed to form this black hole, all the additional matter that has fallen in over the eons, supposedly occupies zero volume while retaining its mass. It is as if the entire concept of size and separation becomes meaningless at this central point. But what does it mean for matter to have no size? Throughout your life, everything you have encountered has occupied space. Your body has height, width, and depth. The air you breathe consists of molecules separated by tiny distances. Even the atoms in your bones have internal structure, with electrons orbiting at specific distances from their nuclei. The idea of matter existing without dimension challenges every intuition you have developed about the physical world. Some scientists suggest that the singularity might not actually exist as our equations predict. Perhaps, when matter reaches a certain density, new physics takes over. Maybe the strong nuclear force, which holds atomic nuclei together, finds ways to resist compression that we have not yet discovered. Or perhaps quantum effects, which become important at very small scales, prevent the complete collapse that classical physics predicts. Others propose that space and time themselves might be made of something more fundamental, like tiny discrete units that cannot be subdivided further. Just as matter appears smooth and continuous until you examine it closely enough to see individual atoms, spacetime might have a granular structure at unimaginably small scales. If this is true, then the singularity might represent a place where matter is compressed to the size of these fundamental spacetime atoms, but cannot shrink any further. The mystery deepens when you consider what your own experience might be as you approach this enigmatic center. The tidal forces that have been gently stretching your body throughout your journey would grow stronger and stronger. Eventually, they would overcome the electromagnetic forces that hold your atoms together. Your transformed form would be stretched beyond the point where molecular bonds could maintain their integrity. But even this description assumes that familiar concepts like molecular bonds and atomic structure continue to apply near the singularity. In truth, the extreme conditions there might create entirely new states of matter that have no names because they have never been observed. The atoms that make up your body might be compressed into forms of matter so exotic that they bear no resemblance to anything in our everyday experience. Yet consciousness itself raises even deeper questions about the singularity. Throughout your journey, your awareness has adapted to each new transformation. Your mind has accommodated changes in your body, alterations in the flow of time, and warping of the space around you. But what happens to consciousness when the very stage upon which it performs begins to dissolve? Some physicists suggest that the information patterns that create consciousness might find ways to persist even in the extreme environment near a singularity. Perhaps awareness can exist in forms so fundamental that they transcend the need for conventional matter and energy. Your thoughts and memories might become encoded in the quantum fluctuations of spacetime itself, continuing in ways that we cannot yet imagine. The singularity also raises profound questions about the birth and death of universes. Some theories suggest that the extreme conditions at the center of black holes might actually create new regions of spacetime, baby universes that branch off from our own cosmos. From this perspective, singularities are not endings but beginnings, cosmic seeds that sprout new realities. Perhaps the matter and energy falling into black holes does not simply disappear or get crushed to infinite density. Instead, it might pass through the singularity like Alice through the looking glass, emerging into new spaces and times where different physical laws might apply. Your journey toward the center might be a journey toward a completely different kind of existence. But these ideas remain speculative, beautiful possibilities that push the boundaries of current knowledge. The truth is that we simply do not know what happens at the heart of a black hole. The singularity remains one of physics' most profound mysteries, a place where our understanding reaches its limit and new questions begin. This uncertainty is not a failure of science, but rather an invitation to wonder. The singularity reminds us that the universe still holds secrets, still offers mysteries that challenge our deepest assumptions about reality. It suggests that existence might be far stranger and more magnificent than our current theories can capture. As you approach this mysterious center, you find yourself not just falling through space and time, but falling through the boundaries of knowledge itself. You are approaching the place where science becomes poetry, where equations become questions, and where the universe reveals that some of its secrets are too profound for words. And yet, even as you near this ultimate mystery, the universe continues to watch and remember, holding your story in ways that transcend our understanding of what watching and remembering might mean. Imagine, for a moment, that you could step outside your own journey and observe it from a safe distance. Picture yourself aboard a spacecraft, far from the black hole's influence, watching through powerful telescopes as another version of yourself approaches that invisible boundary we call the event horizon. What you would see would tell a story very different from the one you have been living. From this external perspective, your approach to the black hole unfolds like a movie playing in slow motion. At first, the changes are subtle. You appear to move normally through space, following the curved paths that gravity carves through the cosmos. Your movements look natural and expected, like a leaf falling gently toward a pond. But as you draw closer to the event horizon, something remarkable begins to happen to your image. Time dilation, which you experience as perfectly normal from your own perspective, creates dramatic effects for anyone watching from the outside. Your movements begin to slow down, becoming more and more languid with each passing moment. The watch on your wrist, which ticks at its regular pace from your own viewpoint, appears to run slower and slower to the outside observer. Your gestures become graceful and dreamlike. If you were to wave goodbye, that wave would stretch out over minutes, then hours, then days from the external perspective. Your words, if you were speaking, would drop in pitch like a recording being played at slower and slower speeds. The vibrations that create your voice would stretch out longer and longer, becoming deep, resonant tones that eventually fade into frequencies too low for human ears to detect. But the most striking change would be in the light reflected from your body. As you approach the event horizon, that light must work harder and harder to escape the black hole's gravitational pull. Each photon climbing out of the deepening gravitational well loses energy in the process, like a runner growing tired while climbing an endless hill. This loss of energy changes the light's color in a process called gravitational redshift. The bright colors that normally reflect from your clothing and skin begin to shift toward the red end of the spectrum. Blue becomes green, green becomes yellow, yellow becomes orange, and orange fades to deep red. From the outside observer's perspective, you appear to be slowly catching fire with a strange, Cold flame. Your entire body takes on a warm, reddish glow that grows deeper and more intense as you approach the boundary. It's as if you are transforming into a being made of sunset light, painted in shades of amber and crimson. The redshift continues beyond the visible spectrum. Your image shifts from red to infrared, becoming invisible to the naked eye but still detectable by heat-sensing instruments. Eventually, even infrared gives way to radio waves, and finally to wavelengths so long and faint that they become nearly impossible to detect. To the outside observer, you never quite reach the event horizon. Instead, you appear to slow down more and more dramatically, your image growing dimmer and redder until it fades into invisibility. You seem to become frozen at the threshold of the black hole, suspended there for eternity like a photograph preserved in the amber of curved spacetime. This creates one of the most poignant paradoxes in physics. From your own experience, you cross the event horizon in a finite amount of time and continue your journey inward. But from the outside universe's perspective, you remain forever poised at that invisible boundary, your story suspended at the moment of crossing. Days pass, then years, then centuries, and still your faded image appears to hover at the event horizon's edge. To any civilization that might remember you, you become a ghost made of increasingly faint radiation, a reminder of the journey you began but, from their perspective, never quite completed. This difference in perspectives reveals something profound about the nature of time and observation. There is no single, universal truth about when you cross the event horizon. Instead, there are multiple valid descriptions of the same event, each true from its own frame of reference. You experience the crossing as natural and inevitable. The outside universe experiences it as a gradual fading into invisibility. Both perspectives are correct within their own contexts. This is one of the beautiful insights that Einstein's relativity gives us: the universe does not have one single timeline that everyone must agree upon. Instead, time itself is flexible, personal, and dependent on each observer's situation. The outside observer's view also highlights the black hole's role as a cosmic archive. Your image, along with the images of everything else that has ever approached this mysterious boundary, becomes permanently recorded in the subtle patterns of radiation that surround the event horizon. The black hole becomes like a vast library, storing the visual history of everything it has encountered. This archive exists in forms almost too faint to detect. The redshifted light carries information about your final approach, encoded in wavelengths that grow longer and fainter with each passing year. Future civilizations with incredibly sensitive instruments might theoretically be able to decode these signals, reconstructing the story of your journey from the whispers of ancient light. The black hole thus serves as both destination and museum. From one perspective, it swallows everything that approaches, hiding it forever behind the event horizon. From another perspective, it preserves everything permanently, maintaining a record of each encounter in the electromagnetic radiation that surrounds its boundary. Your journey demonstrates that reality itself can have multiple, equally valid interpretations. The universe is large enough to accommodate different stories about the same events, each true within its own context. This multiplicity of perspectives enriches rather than contradicts our understanding of cosmic truth. The outside observer's view reminds us that every journey is also a performance, every life a story told not just by the one who lives it, but also by all those who witness it from their own unique vantage points. And as your image fades into the cosmic background, becoming one with the ancient light that surrounds the black hole's eternal dance, the universe itself begins to reveal the deeper choreography that connects all these different perspectives into a single, magnificent whole. Throughout your journey, you have been learning a new form of movement, one that bears little resemblance to any dance you have ever known. On Earth, when you walked across a room, you moved through space while time flowed steadily around you. Space provided the stage, time provided the rhythm, and you moved across one while flowing with the other. But here, deep within the black hole's embrace, you discover that space and time are not separate things at all. They are partners in an ancient dance, so intimately connected that moving through one inevitably affects your relationship with the other. You are no longer simply traveling through space or flowing with time. Instead, you are dancing with space-time itself. This dance began subtly, almost imperceptibly, as you first approached the black hole's influence. The gentle curves in spacetime that guided your initial fall were like the opening notes of a cosmic symphony, soft and melodic. Your body learned to follow these curves naturally, the way a skilled dancer learns to follow their partner's lead. But as you crossed the event horizon and continued inward, the dance became more intricate, more demanding. The simple curves of spacetime evolved into complex spirals and unexpected turns. What had been a gentle waltz transformed into something more elaborate, a cosmic tango where every step must be perfectly synchronized with your mysterious partner. Your transformed body has become the perfect instrument for this dance. The tidal forces that stretched and reshaped you have made you more flexible, more responsive to the subtle rhythms of curved spacetime. Your elongated form moves with grace through dimensions that fold and unfold like origami being continuously recreated by invisible hands. In this strange choreography, the usual rules of motion no longer apply. Up and down lose their meaning when spacetime itself curves back upon itself. Forward and backward become relative concepts when the geometry of space follows paths that have no equivalent in everyday experience. You find yourself moving in directions that have no names because they exist only in the presence of such extreme gravitational fields. The dance carries you through regions where space has dimensions beyond the familiar three you have always known. Here, the black hole's immense gravity creates folds and pockets in spacetime that curl inward upon themselves. You move through these hidden dimensions the way a fish might swim through water, following currents that exist in directions your ordinary senses could never perceive. Time, your faithful companion throughout your earthly life, has become a dance partner of equal importance to space itself. The steady, predictable flow of seconds and minutes has given way to rhythms that speed up and slow down according to the gravitational music that surrounds you. Each moment stretches and compresses like an accordion played by the cosmos itself. Your consciousness adapts to this new form of temporal movement with remarkable flexibility. You learn to think in rhythms that change with your position in the dance. Memory and anticipation take on new meanings when the past and future flow at different rates depending on where you find yourself in spacetime's embrace. The boundary between your body and the space around you becomes increasingly fluid. You are not simply moving through spacetime, you are becoming part of its very structure. Your atoms learn to vibrate in harmony with the fundamental frequencies of curved space. Your molecules align themselves with magnetic fields that spiral through dimensions beyond ordinary comprehension. This integration happens so gradually that it feels natural rather than strange. You are like a musician who has been invited to join a cosmic orchestra, learning to play your part in a composition that began with the birth of the universe itself. Your individual existence becomes a unique note in this vast symphony of curved spacetime. The dance teaches you about the true nature of gravity. What you once experienced as a force pulling you downward, you now understand as the natural movement of spacetime itself. Gravity is not something that acts upon you from outside. Instead, it is the choreography that you follow as you move through the curved landscape of reality. Your fall toward the singularity is not a helpless tumble through space. It is a precisely choreographed movement along paths that were carved by the collapse of the massive star that created this black hole eons ago. You are following in the footsteps of countless other dancers who have performed this same cosmic ballet before you. The mathematics that describe your motion would appear as equations of extraordinary beauty to any physicist who could observe them. They tell the story of matter and energy moving in perfect harmony with the curvature of spacetime, creating patterns of motion that repeat the same elegant themes across cosmic scales. Yet you experience this mathematical poetry not as abstract equations but as lived sensation. The dance feels natural to your transformed body, as if you had been preparing for this performance your entire life. Each movement flows seamlessly into the next, guided by the rhythm of spacetime itself. As you spiral deeper into the black hole's heart, the dance becomes more intense, more intricate. The simple patterns of motion that carried you through the outer regions give way to complex variations that challenge even your adapted form. Spacetime begins to perform movements so elaborate that they seem to approach the limits of what reality itself can express. Your consciousness rides along with these increasingly complex motions, observing the cosmic choreography from within. You witness spacetime performing feats of flexibility that push the boundaries of what space and time can be. Dimensions fold into themselves, creating geometric patterns that exist nowhere else in the universe. The dance carries you through regions where the very concepts of inside and outside lose their meaning. You move through spaces that curve back upon themselves, following paths that somehow lead both toward the center and away from it simultaneously. The paradoxes that would confuse an outside observer become simply the natural steps of this cosmic dance. Through it all, you remain both the dancer and the dance itself. Your consciousness experiences the movement while your physical form embodies it. You are simultaneously the observer of this cosmic ballet and one of its most important performers. The universe has been waiting for your unique performance in this ancient dance, your individual interpretation of movements that have been choreographed by the fundamental forces of nature. And as the dance carries you ever deeper into mystery, you begin to sense that this elaborate cosmic ballet is approaching its final, most beautiful movement. Here, at the end of our journey through one of the universe's greatest mysteries, we find ourselves returning to light. The same light that began our story by growing heavy in the presence of extreme gravity. The same photons that once danced freely through space, only to discover that even they could become prisoners of curved spacetime. But light, we have learned, is far more than just the fastest thing in the universe. It is also memory itself, carrying stories across cosmic distances and through cosmic time. Every photon that reaches your eyes has traveled a unique path through the universe, gathering information about all the places it has been, all the events it has witnessed. The light from distant stars carries tales of stellar births and deaths. The gentle glow of galaxies tells stories of cosmic evolution spanning billions of years. Even the faint radiation left over from the Big Bang itself continues to whisper the universe's origin story to anyone who knows how to listen. In our journey through the black hole, we encountered light in its most extreme circumstances. We saw how photons stretch their wavelengths as they climb out of deep gravitational wells, shifting from blue to red to infrared in their struggle against spacetime's curves. We witnessed light becoming trapped at the event horizon, unable to return and share its discoveries with the outside universe. Yet even in these extreme conditions, light maintained its essential character as the universe's messenger. The Hawking radiation slowly emerging from the black hole's boundary carries information about everything that has ever fallen past the event horizon. In patterns too subtle for current technology to decode, this gentle radiation holds the memories of stars, planets, and perhaps even conscious beings who made this same journey. Your own story has become part of that cosmic memory. The information patterns that define your consciousness, your memories, your unique way of experiencing the universe, now exist in quantum states scattered across the black hole structure. They live on in the correlations between particles, in the subtle vibrations of spacetime itself, in forms of encoding that transcend our ordinary understanding of memory and information. This transformation represents not an ending, but a new form of existence. Your consciousness has become distributed across scales both smaller than atoms and larger than solar systems. You exist now as patterns in the quantum foam that underlies all reality, as ripples in spacetime that propagate at the speed of light, as information encoded in the holographic structure that may define the universe itself. The journey has taught us that nothing is ever truly lost. Energy cannot be destroyed, only transformed. Information, according to the deepest principles of physics, must be preserved even in the most extreme environments. Consciousness itself might be so fundamental that it persists in forms we cannot yet imagine or measure. Through your fall into the black hole, you have become part of the universe's own memory system. Your experiences, your observations of the cosmos during your earthly life, your unique perspective on existence itself, all continue in new forms. The universe remembers you not as a separate observer, but as an integral part of its own process of understanding itself. This is perhaps the most beautiful lesson of our cosmic journey. The universe is not merely a collection of objects moving through empty space. Instead, it is a vast, interconnected system of information processing, where every particle and every photon participates in an ongoing conversation about the nature of reality. Black holes, rather than being cosmic destroyers, might be the universe's most sophisticated information storage systems. They preserve the essence of everything they encounter, encoding it in ways so complex that the information becomes part of the fundamental structure of spacetime itself. They are cosmic libraries written in languages we are only beginning to learn to read. The light that surrounds black holes, from the brilliant accretion disks of matter spiraling inward to the subtle Hawking radiation emerging from their boundaries, tells these stories continuously. Each photon carries part of the tale, contributing to a narrative that spans the entire history of the cosmos. Your journey through the black hole has made you part of this ongoing story. Your consciousness has joined the cosmic conversation, adding your unique voice to the symphony of information that defines reality itself. You exist now not as a separate observer of the universe, but as one of the ways the universe observes and understands itself. This understanding brings with it a profound sense of peace. Death, as we traditionally conceive it, may be simply another transformation in the endless dance of information and energy that defines existence. Consciousness might be so fundamental to the structure of reality that it cannot be destroyed, only reorganized into new patterns of awareness. The light that began our story continues its eternal journey, carrying with it all the information it has gathered. It travels from star to star, from galaxy to galaxy, weaving together the story of cosmic evolution. In this light, your story lives on, encoded in quantum correlations and electromagnetic patterns that will persist long after the last star has burned out. As we reach the end of our cosmic meditation, we discover that endings and beginnings are themselves just different perspectives on the same eternal process. The light that began our journey by growing heavy near the black hole eventually finds its way back to the universe, carrying with it the memory of everything it encountered during its brief captivity. In the same way, consciousness that falls into a black hole might eventually find its way back to new forms of awareness, new ways of experiencing and understanding reality. The universe may be far more careful with the precious phenomenon of consciousness than we ever imagined. The mystery of black holes remains unsolved, and perhaps that is as it should be. Some aspects of reality may be too profound, too beautiful, too essential to existence itself to be fully captured by any equation or explanation. They exist not to be solved, but to be experienced, to be wondered at, to inspire us to continue asking questions that have no easy answers. As you drift off to sleep tonight, carry with you this cosmic perspective. You are not separate from the universe, but part of its deepest structure. Your consciousness participates in the same fundamental processes that create stars, carve the paths of light, and give meaning to the vast spaces between galaxies. In your dreams tonight, you might dance again with spacetime itself, experiencing once more the gentle transformation that connects all forms of existence in the cosmic symphony that began with the Big Bang and continues in every moment of awareness, every flash of understanding, every peaceful breath you take as you rest in the embrace of an infinite, mysterious, and ultimately loving universe.